Bismillah ar-Rahman ar-Rahim, by the name of God, most merciful, most kind. Peace be upon you all. This is Magid Kamel, and we are going to talk about a new subject, which is the inverse of matrix by using elementary row operation. Our matrix is 2 by 2. The second point is use elementary matrices to get the inverse of a matrix 2 by 2. We'll move to the next slide. The first method that we are going to use to get the inverse of a matrix is by using augmented matrix. We are familiar with the equation AX equal to B. If we are going to use the augmented matrix, we just use the A on the left side and the B on the right side, and we put that line, means that it is augmented matrix. The operation is converting A into an identity matrix. Actually, if the X is A minus 1, then when you multiply the A by the A minus 1, which is the inverse of A, you will get an I. This is the case here. A multiplied by the inverse of A, which is the value of X, we get I. We are going to perform linear operations. What happened that we will multiply the inverse of A by A, again multiplied by the inverse of A. Inverse of A multiplied by A will give us I, so we will come to have a relation that I multiplied by the inverse of I is the inverse of A. So we start with the right side identity matrix and we end to the left side of identity matrix, and the right side is the inverse of matrix A. This is the identity matrix, which has a diagonal of 1 and all other elements are 0. This is in the case of 3 by 3. We have 3 rows and 3 columns. While for the case of 2 by 2 matrix, we have diagonal 1 and 1 and the other elements are 0. Okay, we'll move to the next slide then. What are the elementary row operations? Actually, there are 3 operations. Swap rows, which means that you could move the entire row, say from row 1 to row 2 or row 3 if you have 3 by 3 matrix. Second operation is multiply or divide each element in a row by a constant. Suppose you want to double the value of one row, so you multiply, say, by 2, first row, second row, or by 3, or divide by 1 over 2. The third operation is replace a row by adding or subtracting a multiple of another. You want to, this is frequently used in case of L by U decomposition, which we are going to discuss later, that we are saying we will multiply 5 times row 1, and the result we will add to the second row or to the third row to eliminate one element. Okay, this is a practice problem. Find the inverse of 2 by 2 matrix. Our matrix is A. The elements are minus 3, minus 2, 7, and 4. We will use the augmented matrix, which is A augment I. So we are going to write the content of matrix A on the left-hand side of this dotted line. We have minus 3, minus 2, 7, and 4 here. And the identity matrix for the 2 by 2 will be diagonal as 1, and the 2 other elements are zeros. First, we want to convert the left-hand side into identity matrix. We have minus 3 here. We want that element to be equal to plus 1. So we are going to multiply minus R1 over 3. This operation will be done in the R1. So we are going to divide minus 3 by minus 3. It will become 1. And for the second row, which is for the first row, second element A12, which is minus 2, we are going to divide by minus 3. So we have plus 2 over 3. This is For 1, we will multiply by minus 1 over 3. It will become minus 1 over 3. 0 will remain 0. There is nothing, no change in the second row, so we are going to write it again. To the left side 7 and 4, and the right side is 0 by 1. We will move to the second element, a to 1. We want this element to become 0 because we want to have identity matrix here. We have 1, 1, 0, 0. We need 7 to become 0. So what we are going to do is, using plus 1, we will multiply by minus 7, the first row, and then add to the second row, which is another operation, minus 7 R1 plus R2, put it in R2. So the first row is still the same. Here is the first row. The second row, minus 7 by 1 plus 7, it will become 0. Minus 7 multiplied by 2 over 3, it will become 14 over 3, minus, and we add to the 4, we get minus 2 over 3. 0 multiplied by minus 7 will become 0, and 1 multiplied by minus 7 R1, minus 7 multiplied by minus 1 over 3, it will become 7 over 3. We add to 0, we have 7 over 3. Minus 7 multiplied by 0 is 0. We add to 1, so still have this one. Again, we want to convert this into identity matrix. We need that figure. Instead of being minus 2 over 3, it will become plus 1. So we will multiply by its reciprocal, but we change the sign. We multiply by minus 3 over 2, the second row entirely. The first row will be the same. Second row, minus 3 over 2 by 0, it becomes 0. Minus 3 over 2 by 2 over 3 minus, it will become plus 1. 7 over 3 multiplied by minus 3 over 2, 3 goes with 3, and we left with minus 7 over 2. Here, minus 3 over 2 multiplied by 1 is minus 3 over 2. The next step is letting 2 over 3 equal to 0. So we are going to utilize the plus 1, which is element A to 2. We move to the next slide then. This is what we want to become 0. So we'll multiply minus 2 over 3 by R2 and add to R1. Minus 2 over 3 by R2, we start to multiply by 0, so no change, and add to 1, so 1 is the same. Minus 2 over 3 R2 plus 2 over 3, it will become 0. Minus 1 over 3 multiplied by 2, minus 2 over 3, it will become plus 2 over minus 2 over 3 multiplied by minus 7 over 2, it will become plus 7 over 3, and we add to minus 1 over 3, so we have 2, and this 0 we have here, minus 2 over 3 by minus 3 over 2, it will become plus 1, we add it here into 1. The second row is the same, no change, 0, 1, minus 7 over 2, minus 3 over 2. What happened then? That we have obtained the identity matrix on the left side, then accordingly, due to use this augmented method, we will have at the right side the inverse of matrix A, which we are looking for. This is the inverse matrix. Second method is by using the determinant and the cofactor. For 2 by 2, in order to get the inverse of the matrix, we will make swap. 4 will come here, and minus 3 will move down, while we change the signs of minus 2. It will become plus 2, and this is minus 7. But again, we are going to divide all this matrix by the determinant. What is the determinant value? We'll multiply minus 3 by 4, minus the multiplication of minus 2 by 7. So we have minus 12 plus 14, we have plus 2. We are going to divide all the elements by plus 2. So the inverse of matrix A will be 2 plus 1 minus 7 over 2 minus 3 over 2, which is matching with the inverse of matrix A that we have obtained by using the augmented matrix. We'll move to the next slide. In the next slide, we have a definition of the elementary matrix, that the elementary matrix is a square matrix that is equivalent to the identity matrix after one elementary row operation. This is the identity matrix, one at the corner, two corners, the diagonal, and zero in the others. There are three types of this elementary matrix. As we have done operations, the idea of the elementary matrix is we are going to do the same operations, but by multiplying the original matrix A by a matrix from the left side, and the result of multiplication will give us the matrix after the changes we have done. The first element is type 1, which is an elementary matrix obtained by interchanging two rows of I, because we are using 2 by 2. Our matrix, suppose it is A, B, C, D, and we need to change. We get the second row to become the first row and reverse the first row to become to the second. The identity matrix originally was 1, 0, 0, 1. So if we make a swap from the second row and put it as first row, it will become 0, 1, 1, 0. Now try to multiply the type 1E1 by the matrix. So we have 0 by A, 1 by C, it will become C, and 0 by B plus 1 over 1 multiplied by D, it will become D. And here 1, 0, this will become A here and B here. What happened that we have changed the second row to become the first row and vice versa. This is the first type 1, which is obtained by interchanging the two rows of the matrix I. Second type, that if we want to multiply a row, say we want to multiply by 2, by 3 any row, what we are going to do is we are going to write the same matrix 1, 0, 0, 1, but we will multiply. Suppose we want to get 3 times the second row, so we'll put 3 here instead of 1. So instead of 1, we will put our required number. Now let us perform the multiplication process. 1, A is still here, 1 by B, 0 plus B, B is here, and here what happened that 0 by A, 0, plus 3 by C, we have 3C, 0 by B plus 3D, we have 3D. So by putting 3 here, we have multiplied the second row by 3. We have 3C, 3D. This is the second type, or what is called E2. We'll move to the next slide, and we are going to check the third type. Here, we put the 3 here, we multiplied by 0, so we have 0, and 3 multiplied by 1 is 3. The third type is an elementary matrix, which is obtained from the identity matrix by adding multiple of one row to another row. Suppose you want to say, I need 2 times row 1, add it to row 2. This is the operation 2R1 plus R2, put it in R2. So this is 2 by 1, it will become 2, and 2 by 0, it will become 0. Add it to the second row. The second row in the identity matrix is 0 and 1. So 2 plus 0, it will become 2, and 2 multiplied by 0 added to 0 plus the 1, it will become here. There is no change in the first row. So the identity matrix type 3, in that operation, it will become 1, 0, 2, 1. Okay, again, we are going to check it in the ABCD matrix. we have 1, 0, 2, 1. 1, 0, we have A, plus 0, C, we still have A, and 1 multiplied by B plus 0, D is B. After we put the 2, what happened? 2A plus 1C, because we have added 2 times A and added to the second row to C, so it becomes 2A plus C, and 2 times B plus 1D, it will become here. We will find out that this is replacing the 0, which is the position of, we have here 1, 1, 0, 0. Due to using the multiplication and add, this 2 times replacing the original 0 in the identity matrix. We'll move to the next slide. Our idea is to get the inverse of the same matrix which we have started in the beginning of this video. So our matrix is -3, -2, 7, and 4. We want to convert this matrix into identity matrix to get the inverse of its matrix. So we are going to review what were the operations that we have done in order to get the identity matrix from matrix A. The first operation was dividing by 3, -3. So R1 multiplied by -1 over 3. We can use the elementary matrix to perform that operation. So -3, the first row, we multiply by the identity matrix. We have -1 over 3 by 1. It will become -3 over 0 here. And -3 multiplied by 0, it will become 0. While the second row, there is no change in the identity matrix, so it will be kept the same. This is, we call it E1, and we put it at the left side of matrix A. This is the matrix A, -3, -2, 7, 4, and this is elementary matrix for the first operation. We call it E1. We tried -3 by -1 over 3 multiplied by -3 plus 0 multiplied by 7, we get +1. -1 over 3 by -2, we have +2 over 3 plus 0, it will stay here, and this 0, 1, 7, 4, this 7, 4 will be as it is, there is no change. Second operation which we have done is multiplying the first row by -7 and add the result to the second row. We place it in the second row. So what we have done, we have multiplied -7 and 0 to the second row, to the first row, and then we add to the second row. -7 plus 0 is -7, -7 by 0, and add to 1, it will become 1. There is no change in the first row, so the elementary matrix, this will become 1, 0, -7, and 1. It is very important to use the arrangement that this is the second operation, so it will become to the left of the first operation. So A is here minus. This is the result of multiplying E1 by A. This is here, and we are going to use this operation E2. We check 1, 0, there is no change, so we have 1 and 2 over 3. -7, the value is -7 by 1 plus 7 by 1. We get 0. -7 by 2 over 3 plus 4. We have -14 over 3 plus 4, which is -2 over 3. This is the second operation. We'll move to the next slide. For the third operation was multiplying -3 over 2 by the second row. So if we multiply -3 over 2 by the second row, -3 over 2 by multiplied by 0 is 0, -3 over 2 multiplied by 1 is -3 over 2. So this is the elementary matrix after we have done this operation. We will put it here to the left side. We multiply E3 by the result of the matrix as we have obtained. This is the result. Multiplication of E3 by this matrix will give us diagonal 1, 2 over 3, and 0. The next step was turning this one into a 0. Last operation was multiplying the second row by minus 2 over 3 and adding to the first row. So we will multiply minus 2 over 3 R1 and add it to the second row. Minus 2 over 3 by 1. Sorry, minus 2 over 3 multiplied by 0 adding to 1 is 1. Minus 2 over 3 multiplied by 1 and adding to 0 is minus 2 over 3. And the second row is the same. This is the last operation. If we multiply this matrix by this matrix, we get the identity matrix. Now let us review. We started with matrix A, and then we have performed the elementary matrix E1. We have done 4 operations. This is the first operation, this is the second, and this is third, and this is fourth. Let us combine them together. We multiply E4 by E3. We get 1 minus 3 over 2, 1 and 0. Let us multiply E2 by E1. We get minus 1 over 3, 0, 7 over 3, and this is the A. We multiply these two matrices. We get 2, 1, 7 over 2, minus 3 over 2 by A. We get the identity matrix, which means that this is the inverse matrix of A, because we multiply minus A minus 1 by A, we get the identity matrix. So these all elementary matrices, E1, E2, E3, E4, when they are multiplied by each other but using the right arrangement, E4 by E3 by E2 by E1, we get the inverse of matrix A. In the last slide, what happened that we can get the value of matrix A, but by reversing and getting the inverse of these 4. But as you remember from the last segment, we use E1, E2, E3, E4, but this time we will use the inverse of E4, and we put it very close to the identity matrix, and the reverse of 3, the reverse of 2, and the reverse of 1, as we will see here. This is the inverse of elementary matrix E4. This is the inverse of elementary matrix 3, and this is the inverse of the elementary matrix 2, and this is the inverse of elementary matrix 1. So we are reversing the numbering. These are the inverse of these matrices. We multiply all of them together, and then we multiply by I, 1, 1, 0, 0. At the end, we will get the matrix A, the original matrix, which was minus 3, minus 2, 7, and 4. Thanks a lot, and see you next. I'm going to write the link of the post the link of the post for this video. Thanks a lot. See you. Take care.